Okay, and here we are in the last section of 2.5, further applications of right triangles. So you're going to solve problems involving bearing and use trig to measure distance and solve problems involving angles of elevations. Okay, so the first one concept that uses right triangles is the application of bearing when a single angle is given, such as 164 degrees. It is understood that the bearing is measured in a clockwise direction from due north. So this one here would be the 164. You can see it's more than a 90-degree angle, but not quite 180. 164 degrees. There's the north, and then we have our bearing. So here it says try drawing a bearing of 300 degrees. So if I grab my lines, there we go. So I've got it upside down. So point to due north, there we go, and I want 300. So I need to come around more than even a 270 and come up here, and that's going to be my bearing of 300 degrees. This here should be about a 60-degree angle. So I might need to bring this guy down just a little bit. But I'm not going to get out a protractor and measure this. But this would be approximately 300 degrees. Now this is not in standard position, this is bearing. Okay, the second method for expressing bearing starts with a north-south line and uses an acute angle to show the direction, either east or west from the line. So north, 42 degrees east. So on this one particular one, we would be referring to, if I'm looking straight north, I'm going 42 degrees east. This would still also, if we would put this into terms of bearing, this would be bearing of 42 degrees. Now south 40 west, so they're starting from this due south and going 40 degrees west. And this would be a bearing, so I should say this is an or bearing 42, or bearing of, this would be 180 plus the 40, because it's 180 degrees from north to south. So we get 220. So a bearing of 220 degrees. Either or. You can always write each one of these angles one of two ways. So now they want you to do north 52 degrees west. So we got two nice little lines here that we can play with. I bring this guy over here. And I know that about halfway is going to give me 45, so I want just a little bit more. And that should be about 52 degrees. There's north. Oh, we want west. I went east. Oops, let's fix that one. So again, about 45 degrees is halfway, so a little bit more. And then this is west, and this is 52 degrees north, 52 degrees west. Alright, so let's get you working on some of these. And observe for our radar station is located at the origin of coordinate system. So where I was just saying that his station is at the origin. For each of the points, find the bearing of an airplane located at that point. Express the bearing using both methods. Okay. So I'm going to go ahead and draw a coordinate plane on here. Now I'm not going to do exact values. I want 5, 0 from the origin I go over 5 and up 0. So I'm right here. And if this is north, then this would be north 90 degrees east. And if you have to, write it north, south, east, west. That's north 90 degrees east, or bearing and you look at where you are from due north, 90 degrees, bearing 90 degrees. Okay, so once you pause and do this one, see how well you do. Okay, -2, -2 is going to bring us down here-ish. So this is going to be a south so many degrees west. What we need is how many degrees. So if I use my dotted line to close in my triangle here. So I went -2 to the left and then -2 down. So I can use this as tangent to find that angle. So tangent of x, theta, whatever you want to call it, is -2 over -2 or 1. That would make x 45 degrees. How do I know this so fast? Because this is the one I asked you guys to memorize. This is the easiest one to memorize. Tangent at 45 is 1. So this would be south 45 degrees west. Or the bearing. Now we need to know from due north, how many degrees did we go? Well, this is 180 plus the 45. So this is bearing 225 degrees. So let's look over a problem. Okay, distance traveled by a ship. A ship travels 55 kilometers on a bearing of 27 degrees, then travels on a bearing of 117 degrees for 140 kilometers. Find the distance traveled from the starting point to the ending point. So if we look at the picture, so from due north, they have a bearing of 27 degrees for 55 kilometers, and then from that spot, they did a bearing of 117, so they turned quite a bit and went 140 kilometers. Their question is, how far from their starting point are they? So one of the things to do is we got to use some geometry here, is since both of these lines are pointing north, we get to claim parallel lines. And so, and then this would be, so we can, imagine this coming down. But the idea here is that this is 27 degrees, which is going to make this one its complement. So we can look at this going, okay, so this is 27, we have parallel lines, this is 27 degrees, this would be its complement. So 180 minus 27 gives us 3, 7 minus 2 is 5, would give us a 53 degree angle there. Well, actually, I'm doing even more sillier. Nope, that's right. Oh, there it is. 153 degrees. And you might be going, okay, so it's 153 degrees. But what we're looking at is all three of these together must add up to 360. So if I add the 153 to 117, 5, 6, 7, so 270, and 360 minus 270 gives me 90. So this is a right angle here. And that's when you guys should be going, sweet, because now we really don't, all we had to do is prove that this was a right angle, because we have this side and we have this side, and this baby is the hypotenuse. So we get to use Pythagorean. So 55 squared plus 140 squared equals x squared. And 55 squared is 3025 plus 140 squared of 19600 equals x squared. So x squared equals 22625. So let's take the square root of both sides, square root, and we get 150.41. And then we come back going, okay, significant digits on this guy, we're going to use 3. I know we got 2 here, but we have 3 here, so we're going with 3. So x equals 150, but remember, word problems deserve word answers. So let's find the distance traveled from the starting point to the end point. The distance traveled from the starting point we can also call this a displacement, is 150 kilometers. Now, that's not the distance it traveled. Well, it says distance traveled. The distance, maybe we should change that from distance traveled to distance, not distance covered. So it's not the distance covered. The distance traveled is just the distance from the starting point to the end point. So let's take that distance from starting point to end point. That way we can claim this is not the distance traveled. We could add that up and see that they went almost 200 kilometers. But from start to finish, from starting here to finishing here, we're only 150 kilometers from our starting point. Okay, let's try a couple more of these. Okay, where's the problem? In this exercise, in the course of a plane or ship is in the indicated bearing. So distance between 2 lighthouses. 2 lighthouses are located on a north-south line. From lighthouse A, the bearing of the ship is 3,742 meters away, is 129 degrees 43 minutes. From lighthouse B, the bearing of the ship is 39 degrees 43 minutes. Find the distance between the lighthouses. So, get my handy dandy line going here. That's good enough. We don't need. Okay. And I'm going to put up here, lighthouse A is up here, lighthouse B is down here. Now, it says that from lighthouse A, it traveled 3,742 meters, and it is at bearing of 129 degrees. So a bearing of 129 degrees. Now I want to make sure you understand that we're talking this angle here. And then we went 3,742 meters. From lighthouse B, it's 39 degrees 43 minutes. So 39 degrees 43 minutes. They did not give us this value. I don't know if we need it. It says find the distance between the 2 lighthouses. Nope, we don't. This is what we need. So the question is this a right triangle? So keep in mind that this angle will add up. This angle is supplementary. So I know this is 129 degrees 43 minutes. So 180 minus 129 degrees 43 minutes. This is 179 degrees 60 minutes. So 10 minus 3 is 7, 1, 9 minus 9 is 0, 7 minus 2 is 5. So this is inside here, 50 degrees 17 minutes inside here, and we can add these up to see what this angle is. So plus 39 degrees 43 minutes, 10, 4, 5, 6, 98, but this is 1 degree, so we get 90. We've just proven that that is a 90-degree angle. And we want this length, but keep in mind we don't have the other length. So we can use this angle, or we can use this angle. I'm going to use this one. So from this one, this is my opposite side, and this is my hypotenuse. And since I have the opposite and I want the hypotenuse, we're going to use sine. So we have sine of 39 degrees, 43 minutes, equals opposite, which is 3742 over the hypotenuse x. Cross multiply, we get x sine of 39 degrees, 43 minutes equals 3742. Divide by sine, and we get x equals 3742 divided by sine of 39 degrees, 43 minutes. And that gives us an answer of 5.8, and I cannot read my own writing. It looks like 5.6. Yeah, 5.856, and then it goes 0.102023. But if we look up here, 4, 5, 4, we're going to go with 4 significant digits. So 4 significant digits, then we're just going to take the 58, 56. The distance between the two lighthouses A and B is 5,856, and this is measured in meters. And there you have that. The biggest thing is being able to draw these pictures and see if you can get that right triangle so that you can use it. Okay, one problem left, and this one is a doozy, I promise. Okay, solving a problem involving angles of elevation, find h as indicated in the figure. So we have 41.2 degrees on the larger of the two triangles, and then 52.5. The problem is we don't know this, so we're just going to call this bit x. And we have to look at both of these. So when it's, by the way, I should point out, that makes this full length 168 plus x. And that's going to be for this angle. So for both of these, this is the opposite side, and this is the adjacent side. But pay attention, because your smaller triangle is only this bit through here. So we have tangent of 41.2 equals opposite, which is h, over 168 plus x. On the other one, we have tangent of 52.5 equals the hypotenuse h over its side of just x. Now they both have h in them, and they both have x in them. We're looking for h. So the question is we can solve them both to be h equals, or we can solve them to both be x equals, and solve for x and then solve for h. Because I'm going to pause this for a second, because it might be faster to go the other way. Okay, the consensus is we continue on the track that I had decided to do. Alright, so we have these. I know I want h, but what I'm going to do is solve for h, find the value of x, and then solve for h. So the tangent of 41.2, I'm going to multiply both sides by this. So I have 168 plus x times tangent of 41.2, and this one is going to be x tangent of 52.5 equals h. Now that these are both equal to h, that means this guy must equal this guy. So I have 168 plus x tangent of 41.2 equals x tangent of 52.5. Now, I didn't go ahead and set these equal to, so have them x equals, so we can just go and solve for h, because we were working with fractions throughout, and this is going to be a little bit easier to deal with the fractions a little at a time. Okay, this is an algebra problem, a little complicated, but it's an algebra problem. So I need to distribute the tangent into this. So I have 168 tangent of 41.2 plus x tangent of 41.2 equals x tangent of 52.5. I gotta get all my x's to the other side. I am not solving for the tangent values because they're going to just give me these large decimals, and I can't have rounding errors, so I'm just leaving it at this. So I'm going to subtract the x tangent 41.2 minus x tangent 41.2. So I get 168 tangent of 41.2 equals x tangent 52.5 minus x tangent 41.2. Now notice they both have x's, so I can factor out an x. This is still equal to 168 tangent 41.2. Divide both sides by the tangent. And we get x equals this amount, and when I threw that into the calculator, I got an x value of 343.7958689, I don't know, something like that. But this is not what we don't need. This, well, we don't want this really. We kind of need it because that's going to help us get this. Because now I can use either this one, now that I know what x is, I can do this plus this and do x, or I can just use the number here and use this. So I'm going to use a 52-degree angle, which means I'm going to go back to this guy here. Now, I'm going to make a note to keep this in the calculator so I don't have to mess with making sure I have everything right. So tangent of 52.5 equals h over x, or x tangent of 52.5 equals h. Now keep in mind x is all of this, so 343.79 blah 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 times tangent of 52.5 is equaling h. And you throw this back into the calculator, and h is going to give you 448.043. Now I didn't identify significant digits, so we'll come back here and look at that. 3, 3, 3, so 3 significant digits, which would give us just the 448. So the height of the two triangles is 448, and the question is, what is it measured in meters? Done. Now, I can point out that we could have gone straight from way back here and solved for h, or solved in terms of h, and just found h. It may have been a little bit quicker, a little bit faster, but you would have dealt with fractions throughout almost the entire problem. Okay, now the homework didn't print out this one, so I'm going to go ahead and send this one. There's your homework. 5 through 21 odd, 37 through 31 all, and then 35. Good luck.